Hello intellectuals, welcome to my speaking notes. The first problem deals with how to prove De Morgan's law. Now we know that two sets are equal if they are subsets of each other. So the task is very simple, is to show that the elements on the left hand side belong to the set that is on the right hand side and vice versa. So pick an element in A union B complement and show that it belongs to A complement intersection B complement. Next, you are going to show that an element in A complement intersection B belongs to A union B complement. Then you have just proved the De Morgan's laws. The next problem deals with how to sketch the graph of a rational function. Now, a rational function is just a function that is a ratio of two polynomials. So the numerator is a polynomial and the denominator is a polynomial. The first task is to find the vertical asymptote by equating the denominator to 0 and solving for x. Then you find the horizontal asymptote. Now the horizontal asymptote is found by observing the powers of x in the numerator and in the denominator. If the difference is just 1, as in the power of the numerator is 1 less than the power in the denominator, then the horizontal asymptote is equal to, it's the line y equal to 0. And if the powers are the same, then the horizontal asymptote is just the coefficients, the ratio of the coefficients of the highest power. Okay? Next, we find the x-intercept by setting y equal to 0. So equate the function to 0 and solve for x. Then for the y-intercept, set x equal to 0 and solve for y. So putting all the pieces together, I start in the middle by locating the y-intercept, then connect the points. Now on the right side, you can pick any value either on top here or at the bottom. You realize that the graph is positive, so it is up here. On the left side, this is the x-intercept, and then you can pick any value here. You realize that the graph is up, then it goes down. Okay? The next question, I want to show you how to show that two functions are inverses of each other. Now, f and g are inverses of each other if and only if the composite function of f and g is x and the composite function of g and f of x is equal to x. Now, the function f, which is the cube root of that, can be written as the function raised to the power 1 over 3. So you compute f of g of x by setting x equal to the function g of x. So where there is x in f of x, I put the whole function g of x and simplify. Just use the laws of indices. Next, I compute g of f of x. So in the function g of x, where there is x, I put the whole function f and simplify. So you realize that in both cases, the result is x. Hence, f and g are inverses of each other. Very good. The last problem, I just want to show you how to determine the values of x for which this expression is greater than 0. So this is just equivalent to saying solve the rational inequality. So whenever you are solving a rational inequality, please do not cross multiply. What you need to do is to take all non-zero terms to the left side of the inequality. On the right hand side, you need to have a 0. From there, you find the critical points. Now, critical points, these are just values for which the numerator and the denominator is equal to 0. In this case, the numerator is x plus 3 equal to 0, then solve for x, then equate the denominator to 0, solve for x. In that case, the critical points are x equal to negative 3. Next, you are going to perform the sign test. Now, the sign test, you put the critical points on a number line, and look at regions. Now, in this case, there are three critical points. So you have the first region here, then here, here, and here. So you have 1, 2, 3, 4 regions. Okay. So in these 4 regions, you pick a value here before -3 and put it in the whole function and see if it is greater than 0. Okay. So to make that easier, I split the whole function as in x plus 3, x minus 3, and x plus 2. So if I pick a value before -3, let's say -4, the first expression is -4 plus 3, which is a negative number. Then -4 minus 3 is still a negative number. And -4 plus 2 is still a negative number. So this is a quotient, right? So this is negative, positive is, negative, negative is positive, then negative, it's a negative, okay? So in simple terms, if I pick any value after -3 and put it in the whole function, I find a negative number. But a negative number cannot be greater than 0. So I cross this. It is not part of a solution. But between -3 and -2, it is positive. Between -2 and 3, it's negative. And then after -3, you have positive again. So meaning that the solution set are the values that are between -3 and -2 and between 3 to infinity. Now observe that these are open parentheses. Why? Because this is strictly greater than. So I am not including the endpoints. So guys, thank you for watching. Please like, share, leave a nice comment so that we can be motivated to make more videos like this. You can go through again, rewatch, rewind, rewatch, rewind. If something is not clear, just send a comment and then anyone can respond to you or I can respond to you. Thank you.